Good evening. Welcome to our first Friday Tucson Amateur Astronomy Association meeting. We're delighted to have everyone here tonight. It looks like we're gradually still building up, increasing our members that are in attendance. We have both members with us tonight and guests that are on Facebook. And our guests that are on Facebook, we're just delighted to have you join us. We're glad that you're here with us, and we hope that you enjoy our meeting tonight. Our speaker tonight is Joseph Wright. He is an instructional specialist at the Stewart Observatory, and he's a high school teacher with lots of different kinds of skills. And Joe, I don't know if you're ready to screen share yet. Are you set up and ready?
I'm ready.
Okay, well, let's go.
Okay. Good evening, everybody, and thank you for having me here. It's a pleasure. My wife, Rhea, and I joined TAAA a few years ago, maybe 5 or 6, and we know about a dozen people out in Tucson. We live just north of Kansas City, Missouri, out in the country setting on 5 acres. And it's a pleasure to be here with you tonight and see some of the people we know on Zoom and Facebook, David Levy, Tim Hunter, and others. It's a pleasure to see you again, and thank you for having me, as well as the entire TAAA and any of the public guests that are joining us tonight. Thank you. I trust that you can see the screen okay? Okay, so I will make no false pretensions. I am not an expert in building observatories. I've had the opportunity to draw some and build a couple. And it really depends a lot on the person's personal preference. I do want to acknowledge David. He is one of the people that helped me come up with the name for this talk, because I remember a comment one time about ivory towers when he was a youngster. So we'll just go ahead and dive into it. Like Ms. Smith said, feel free to ask any questions. I know there's a number of you out there that already have a backyard or a remote observatory, and feel free to offer any caveats or pitfalls that you fell into, so people, especially those that I don't mention, so our listeners and viewers have a better idea of what might they encounter when they're building a backyard observatory. Tonight, discuss some of the topics, points on this. Of course, what type of astronomer are you? Location, design considerations, local governing codes, covenants, neighborhood associations. Some of you might have dealt with that even with your home setting, painting, any type of add-ons, planting. Construction documents. Also, are you going to be a DIY, do it yourself, or you can hire a contractor, and types of constructions. And as you can see in the image there, I don't know how many people remember, but the original Wolfman movie started off with astronomy. He had returned home to repair his father's telescope. And when I saw that many years ago, I always wanted to keep that picture around because I thought it was most interesting. And I also really admired the telescope. So, what type of astronomer are you? Are you an armchair? Are you an active observer? Do you do visual? Are you an amateur? Do you do astro imaging? Do you like doing outreach? Are you an equipment junkie? Do you keep a stockpile of telescopes around the house? And this goes for anybody. It's just not a male thing, it's a female thing. And it's great to have everybody in the organization or interested in astronomy. And that's one of the things we want to really promote is youth astronomy also. And that also means, are you into outreach? Do you share your time and telescope with the public? Are you going to share your future observatory with the public, and especially the young people that will be coming up behind us as our future astronomers? So there's quite a few different types of astronomers out there. And when it goes to selecting or considering building an observatory, we think about that. Boy, how much time can we save by not constantly dragging things out of the house, the basement, the garage, living room, dining room, getting it outside, getting it set up. We can just go out, open up, roll it off, open the dome, and start observing. And we don't have to lug all that back inside. And if for some reason that the weather turns bad quickly, it's easy just to roll the cover over or shut the dome, and everything is safe. Which leads me into the next question: dome or roll-off? That's the two primary types of observatories out there. I know members of the TAAA and others around the world have each kind, and they both have advantages and disadvantages. So, dome versus roll-off. Some of the advantages: a dome has aerodynamic properties. It's less susceptible to wind unless the slit is in the direction of the wind itself, especially with gusts. That can affect the type of telescope you're using. Is it a large tube Dob or the Schmidt-Cassegrain with a corrector plate up front? Where with the open Dobs, the air is going to go right down the tube. And the dome protects you from that wind, condensation, and the effects of it that you have, especially on cold nights. You don't necessarily have to be looking in the direction of the wind all the time, but at least you can turn that dome and look in a different part of the sky as the wind varies throughout the night. And let's face it, the dome has an iconic look. When you see a dome, an observatory dome, you know instantly what it is. It's not a mystery what's inside there. You know it's an optical piece of equipment. And one of the other big things, advantages, a dome has lower wall heights typically. And you can have nearly to the ground, or you can build a wall height up to 6, 7 feet if you want. It really depends on your preference. Also, many domes are easy to relocate if you were going to move. You can pick up the dome, detach it, and move it more easier than you can a structured built building like a roll-off. Now, on the flip side, the roll-off offers some advantages also. You can have multiple instruments. This also means your friends and family and fellow observers can come over with their instruments or sit in the observatory with you and take part in the night sky along with you. So it's a more of a camaraderie type of environment. Also, the roll-off gives a big picture view. When you're looking up, the whole sky is open. You know, in the dome, you don't get to have that advantage. There's no need to connect the roll-off to a mechanism if you're going to change the direction of the telescope where you're looking. It's already open to the whole sky, so you don't have to rotate it, you don't have to move it. And many times, depending on how elaborate of a structure you have, they can be easier to build. Now, some of the disadvantages: typically domes are more expensive. Those generally refer to prefabricated. There's a host of companies out there that I have towards the end of the presentation that offer all kinds of packages of dome type, size, style, and accessories. As I already said, you have a more confined view. You have a narrow slit that you're looking through. Also, unless you automate the dome, it's going to be manually operated. And this is not necessarily a big problem because generally the rotation, they rotate very easily unless bearings or a wheel gets displaced. The disadvantages of the roll-off: they generally have higher sidewalls just because of the type of construction. With that, if you have to have the wall height above where your telescope is mounted, unless you're able to turn the telescope down on one of its axes, that you can roll the observatory's roof over it without harming it. Also, you're more at an effect of the humidity and the atmosphere. Everything can get wet unless it's covered in a roll-off. So everything is susceptible to condensation and the dew, depending on the area you're at. If you're like I am in the Midwest, during the summer, it's normal to have a 98-degree day with 95% humidity, and that's pretty standard here in the summer. We're out in the Southwest. I know it's not nice to be jealous, but I wish we had more of that 12% humidity when it's time to observe. Also, header clearance is a disadvantage, and that's the height of those walls again. And another issue is snow loading, all right? Depending on where you're at, you can have a large amount of snow at any given time during the winter. It's not common around here that we could have 8 to 14 inches of snow piled up on a roof. And depending on the slope of the roof, it's going to stay there for a while, and that increases your structural load on your roofing members. So there's all types of considerations to make. Also, let's see, space, all right, location. How much room do you have? Are you going to be able to build anything of any size? That might mean that you might want a micro or mini observatory. And in the picture, I've already mentioned weather conditions. I want to assure you that that was a quick photo, so we didn't leave that telescope uncovered. That's a mid-90s LX200 Classic that has been the workhorse here at our house, and we have a similar one that is our outreach telescope. But weather conditions are very important. In areas out that have heavy rainfall, flat roofs still have to have drainage, a minimum pitch to get that rain off, and where's that water going to go around your observatory? So if you're in an area that has a high rainfall, you really want to move that water away from your structure so it doesn't cause any problems, structural problems there. But as I was looking at Google Maps and the Tucson area and picking out places that I could use it as an example, where there's a high population density, as any larger city, as Tucson and Kansas City or any other place, you have very restricted areas by fences, wood, chain link, easements, setbacks, neighbors, and that's really becomes a consideration of what you can build. And I found that very interesting when I was looking at the aerial view of Tucson, that there are a lot of small yards out there where a smaller observatory still can be useful and still be very economical to build and advantageous to have, so you're not constantly setting things up and tearing it down. Because one of the things I haven't mentioned was security. You want to keep your equipment. We have known people to have their equipment stolen, whether in a trailer or in their backyard. One gentleman I know had his stolen while he went inside to take a break, restroom, get something to drink, and come back out, and his telescope was gone. And they had went over the fence and grabbed it and took off in a car. So that's one of the considerations about having any kind of, even if it's a small structure, you can lock it up and slow down the criminals. Excuse me. As in the title of the picture there, that telescope was from the movie It Came from Outer Space, released in 1953. And that was out in the Southwest. And as you can tell by the vegetation around there, and we also found that we like watching old movies before we open the University Observatory here. All right, let's really get into design details and drawings. anytime you're going to go before your local building officials, whether you're inside a city or county, depending on how it's structured, you're going to need some kind of documentation. In many places, as long as it's simple, conveys what you want to do, and is clearly laid out, you don't have to. Also, it's dependent on the area if you need stamped drawings by an architect or engineer. Some locations still do not require this, depending on the size of the structure. This one, as an example, the homeowner took on the responsibility of obtaining the building permit, and so the drawings were not did not require a stamp to be built. This was built south of Kansas City, and the gentleman wanted a dome observatory because he primarily did astro imaging. And so on the drawing, you can see we had a floor plan with some elevations of what it would look like from the outside, from each side as you step around, and then also provided a building section showing approximate locations of stuff. Although they will vary depending on what you're going to be doing. And if you are buying a dome or visit one of the dome manufacturer's website, as in the case of most of them, they have very good plans and details that you can get and use for your own design and use, not without even purchasing their equipment. And we also provided some electrical drawings and framing of the steel in the concrete for his slab for his dome. The biggest issue with building this observatory was getting the delivery of the dome, because the company, the freight company, dropped off a 53-foot trailer from the tractor and left it on a Friday, and they said they would be return Monday to pick up the trailer, and we had the weekend to get a 8x8 square foot by 4 foot high crate out of the back of the trailer onto the ground and into the backyard. So that's where a society, a club, or association comes in handy, getting the manpower to lift it out of the truck and move it into the backyard where we had built the observatory. Conversely, here's a drawing of a Rolloff. Rolloff has a little more detail when you start thinking about how are you going to have the roof actually move. Also, if you're building or thinking about drawing one, there's some free online CAD programs if you would like to, that require a little knowledge of using it, that you can actually go on the internet and get free. And only a couple of these I actually know firsthand, but you can see there's 3D Builder, FreeCAD, LibreCAD, which I believe would be similar to the same company that provides software similar to Microsoft Office. SketchUp I've seen, Tinkercad I haven't. Fusion 360 is a 3D drawing package that's relatively easy to use, learn, and use. And I actually had some students taking that up this past semester at school that had never used it before. And I know that one is available on Mac and PC, and as well as Onshape is another 3D type of drawing package. If another location you might think about searching for somebody to draw your drawings would be a vocational school that has any type of drafting or CAD program, or your first resource would also be if your local astronomy association, and see if they know of anybody that does this type of work. The thing about doing the VOTEC, you can actually talk to the instructors and maybe make it part of the curriculum or project for one or two students for the class. And it might even turn out to be a design competition for the entire class. So you're able to get different ideas from the different students on a way to build it or design it. Not everything's going to be 100% alike, but you might get a little bit of differences as far as how to arrange any type of built-in structures you're going to have. Because let's face it, if you're going to have an observatory, you know you're going to need storage, you're going to need counter space, cabinetry, and contacting those schools could go a long way as getting some of that actually done for you, and also helping other people out learning their industry. As far as the roll-offs, you'll see a variety of different rollers that they use. I have seen flat rollers, in other words, that they are not like the V-groove that is shown in the inset there. Some of them are just typical round 3-inch wide a poly roller or type of steel roller. I have seen them where they just roll on an I-beam that uses side clips to keep it from going from keeping it true down the length of the I-beam. But the most common thing you'll see is using this angle iron as the track for the V-groove. And I'd be curious to know if anybody that's watching has this type on their observatory. I moved my mouse just a second. Now, when we look at domes, no matter what dome you have or what kind of structure, there's always going to be maintenance issues. That's a given. There's nothing that's mechanical that doesn't have maintenance issues. Even on the fiberglass domes, as you well know, the sun and UV light does a lot of damage to them as far as deteriorating their materials. And on this particular dome, you can see that the stops for the dome that comes back, the slit when it opens up, is actually broken off. Now, one of the quickest way to fix this is find somebody that can bend some metal that's 3 or 4 inches wide and bend it up to make some catches to go on there and replace those. But still, there's always going to be maintenance. You're going to have seams no matter what you have, that even when you put the dome rings together, that you might want to go ahead and put caulk in there to help keep moisture out, especially down at the base. If you don't have an angled dome ring like this threshold, that some of these just sit flush onto the ground and they don't have this angled lip. If it is mechanized with power rollers, those shafts can also shear off and break because of the torque. Or if the dome for some reason gets out of round and doesn't rotate easily, these can actually be a problem and would have to be replaced. But that's if you want to have it automated. If you want to hit a switch or have it tethered to the telescope to move with the telescope to always keep the dome opening in front of the telescope. If not, it becomes a manual operation, which isn't difficult to do. Oh. So either one you do, you're going to have some kind of foundation. This one here is for the dome. You can see we have the foundation for the control building and the pad where the dome's going to go being placed. You can see the rebars in place. And then we have the hole for the pier. This is about 30 inches in diameter and about 4 feet deep for the concrete pier for the telescope. Now, you don't have to have a form go all the way down into the ground for the pier, because you want the concrete up as tight as possible to this. You do want to isolate any pier from the floor structure, no matter what you have, if it's wood or concrete. So any kind of movement of the floor doesn't affect the telescope base. And then just the gentleman putting the concrete in the forms and vibrating in place. And this is what you're going to have depending on what kind of system you're going to put in. And you can see electrical power and communication power, all right, with large enough conduit that you can get all your connections and everything through. And there is still a fiber band that goes around this ring, so it's isolated from the rest of the floor. And even if you're outside, you always want to have it above the water line or the ground line, so water doesn't get in there. But an excellent thing to use is what you'll see on a lot of architectural drawings called backer rod and caulk, where it's a foam that they put in there, they push it in, then they caulk in behind it, and you're able to fill larger gaps. And it gives that a compression area for any kind of movement, so it doesn't affect whatever pier you're using. No matter if you're putting a pier in, either concrete, if you're having a concrete pier, of course, you're going to bring it up as high as you want it above the floor. This gentleman had a metal pier that he was going to bolt right onto these bolts that are placed down in the concrete during the pour. Now, problems that you encounter. I see them. I have a V-groove roller. All right. Gary Steffens has the V-groove roller. Have you encountered any problems with those, Gary? Okay, he says no. And yes, they work great. Yes, they do. And James, and I'll probably get this wrong, McShahey, he has, yes, the garage doors. And thank you for reminding me of that. Garage door track and rollers work excellent for observatories. And even for the roll-off, as he is mentioning in the text, there's different ways to have the front of the observatory on a roll-off done for you to have more exposure to the south. And I apologize. I actually had that on the slide. I should have mentioned it on the drawing where I had noted that there was a opening that the gentleman wanted. Actually, I should, pardon me for this. But this one here with the roll-off, with the X-bracing to keep everything from moving. And he has on the south wall here, this is a drop down. And he could have just as easily, if this gentleman wanted to drop down, it had made this where it actually goes up just like a garage door overhead, or make this entire section like a garage door and have it go up onto the roof and roll back with the roof and put some stops in there and pins to keep it from moving accidentally. And then you can have a complete south view open for a roll-off. Thank you for reminding me that, James. So this is on this one, one of the problems we encountered, the site plan that the homeowner had and what we actually measured had a conflict on where this fence and the propane tank was. And where the property line was. It was actually closer than noted on the original drawings. And in order to get the electricity out to his observatory, we had to go around this way because there's a pool in the way. And this is about 200 feet of trenching, and we actually lifted the propane tank out of the way and went under where the propane tank was, backfilled it in, and put the propane tank back in place. And that is one of the things that you can run into if you're out where you don't have what we'd call like city service, where you're not on a gas line coming from the city, where you are heating with, actually, I believe this tank actually only heats the pool and carries gas to the barbecue grill. But still, many people out in the rural areas, this is their only heating source, and that's a consideration. You have to be able to disconnect this, shut everything off, move it, and put it back in place. And I might add, getting proper electrical service and sizing your wire is very important, especially with delicate equipment like we have in astronomy. So you really want to pay particular attention to getting somebody that knows something about electricity, that they can wire in the service so you don't have any fluctuations, especially for CCDs, the telescopes, any other equipment that you're running. And I believe we took about 100 amps out to that observatory building. And this was 3/0 wire. So this is about 5/8 of an inch thick cable that we pulled. And this is what I want to also mention about codes. Even if you're in an area where there is no code enforcement, find the closest local code or any code you can find and build to a code, because you're protecting yourself, your family, and your visitors. Not to do that just would be wrong. And cutting corners where it's a safety concern is not worth it. And I've heard other people, oh, there's no codes out here. Well, there isn't, but you still want to do things to them, because it is, remember, the minimum codes. All right. So don't go below the minimum. Just to cut a shot, we did standard 2x4 framing and installed a metal door. And we tried to make sure he had outlets as often as we could and for all his equipment. The other interesting thing about this facility, that if they moved, this could become a guest house. Yes, it has no plumbing, but it's not far from the house. Also, it could become a changing area for the pool. So in this case, having a structure built actually had a second use, even if they move. Then you want to try to make the dome as round as possible, is what we're doing here. And I will add that we had about 9 gentlemen and a few ladies from the Astronomical Society of Kansas City out here when we were doing some of this and lending a hand, especially when it came to moving all these pieces out of the crate back into the backyard. And you can see all these are spots for the rollers and dome motors and controls. Just a part of the door window trimming. The nice thing about being able to do it yourself, you can go pick out the lumber. You don't depend on just what the lumber company is going to send you. Everything in this observatory was selected for stain, but they decided to paint it. This is the service going out to the dome, where we have the communication lines, and on the other side is the electrical. And then these are some gussets to hold up the countertop that we made. And the gentleman, actually, he is a retired medic. Well, at the building of this, he wasn't retired, but he is a MD and also a rocketeer. He was one that would go out to Western Kansas and launch large rockets. But this is his previous telescope, at LX200 Classic 12-inch, and now he has the 16-inch later model. And you can see here's the drive motor, and you can see the rollers for the dome. Even without a drive motor, these roll very easily around. And there's enough room for people to get in there. Of course, we think about the heat buildup in there, but primarily you can see he's doing imaging with an S-Big camera. This is the inside of the course, as you know, the opposite end from where he sits, and put in some cabinetry, what we call a hotel unit that is a heating and air conditioning unit. The structure is fully insulated. And then you can see some of his photographs that he has on the wall. And there's where he sits and controls it. And we did put some windows in. Let's face it, it's nice to be able to look outside either day or night. And he has what many of you would have in your own, a camera on the scope, one on the dome, so he can see the telescope, and he can see looking out the dome, and then his computers for controlling everything, and his book collection that he has out in the observatory. And there's the finished observatory. Okay, I went going a little longer than I anticipated, but here's a roll-off, and I think many of you might know this observatory. The gentleman's with us tonight. And the thing about roll-offs, it's like building a garage. Sometimes you don't have a large enough garage because you collect too many tools or stuff, and you add on to it. So he has added on to his first structure, and you can see this second roof rolls over the first. Here's the entrance into it, and then the tracks are for the first one are here. Well, here is a better shot here, and he also has, I think I have a shot of it, maybe not, the opening that opens up to the south side that goes up overhead. And this is 2x4 construction. And you can see that the hurricane clips to keep the ceiling joist in place, which is required by codes. And you can see the bracing in between the joist up above. Here's his roll-off. That's right, it goes up into the housing here, an accordion style, very nice, very efficient, easy to take care of, and just makes a nice opening. That's the second option about other than using the garage doors or the tilt down. Another observatory near the same location. Again, the classic V-groove rollers. And here's the rail to helps keep it in place and keep it parallel as it's going down the track. And you can see this is steel construction with a stop. And you don't necessarily need one on each side, but a stop that can is used to stop it. Now, one of the things you can use to open some of these I have seen is the garage door opener. And the last type of roll-off, this is at Powell Observatory, south of Kansas City, that the ASKC owns. We dedicated this to the community that was providing the park where the telescope observatory is at. And this one has two that I want to talk about. Lastly, the roll-off with a shed roof and this flap door that comes over the front here that actually has a locking mechanism that makes it more secure, that this comes down and locks the two swing doors and the one swing door in place that's oversized. And we're able to put a 16 and a 12-inch in there. And generally we carry the 12-inch out here into the grass and leave the 16 to be used inside during the public nights. And you can see, just like the previous slide, that it is all metal construction with the structural piping going down out to the field here for the roof to slide off on. And you'll see various different configurations of this type of shed roof. But back here is one that I want to kind of go into next. Oh, but these are the other rollers I was referring to, and that's what we have on this one here, where they're just a flat steel roller on the steel surface here, and they roll really good. This here has been replaced by a dome, but this is something that in a confined backyard, somebody can relatively easily build. It's about a 4x4 structure, and each side tilts down, and there's pins that you pull from the top to fold these leaves out. Then it has one little curved rooftop that goes over it, kind of like a glorified outhouse or porta potty. But it worked fabulous for about 10 years until we upgraded to a dome, and this is an LX200 Classic. And so into the many observatories, you can still do visual or CCD imaging, just like this one here. This was David Hudgens from Kansas City, and he has, I believe this is a 10-inch LX200 with an S-big camera, and this is right out his back of his house in suburban greater Kansas City area. And he runs it from right inside his basement wall here. So if you have a setup where you can easily get to an adjoining wall where you can put conduit through into the house, you can control it from your basement or a extra room in your house. Similarly, these here are a couple of roll-offs. Now, this is the whole structure. This telescope here was built started in 1952. It took 10 years to build, and the gentleman built it for his wife. It's a 16-inch, and he actually built this structure. This is on the roof now at the University of Missouri, Kansas City, and they used a crane to bring each of these up onto the roof. Naturally, they took everything out took the mirror out, and it is an exquisite mirror. But he has what we call the landing gear. These have a crank that you can stand up here and crank these down. It lifts up this unit and it rolls right back into here, exposing the 16 for our public nights. And then this one was built back in 2012. Let's see, this one's donated in 1972. This is 2012, and it's a heavier steel, and it houses the 14-inch Meade. And one of the requirements being inside the city of Kansas City proper was the concern of stray gunfire penetrating it. So to test some of the metal, we took a piece, laid it in the ditch at my house, and fired 5 rounds of 38 into it, and it didn't penetrate. So we are sure that any free-falling projectiles are not going to go through it from a handgun or rifle. But it's just emphasis here was to show you the variety of different observatories that you can have on a small budget in a small confined area that oh yes, they are pneumatic wheels. We just replaced them 2 years ago after the original wheels, believe it or not. That's how long they last out there in the weather. And so yeah, Chris, yeah, and they only, I think it cost us $60 to replace the wheels. So they worked great for that long. This here, the gentleman, as you can see, bought a shed and modified it and has a roll-off roof on it. Right, and I'm talking about free fall, not someone actually aiming at it. So far, that hasn't happened, thankfully. And he's modified this garden shed to turn it here into their backyard observatory that works relatively nicely. Also prefabricated, all right? I don't know exactly all the suppliers out in the Southwest around here. Tough Sheds is one. I know all your big home stores, Lowe's, Home Depot have pre-made garden sheds. They range in prices from, I don't know, $1,500 to $2,300. They'll drop it off at your place all ready to go. And you can modify the floor with a ramp if you have some kind of scope cart or buggy where you can roll your telescope out. It still saves you time. You can have your setup inside and you're observing very quickly. And then Rubbermaid provides these sheds. And I actually tried contacting Rubbermaid to ask them what kind of guarantee that they offer for outdoor exposure, especially UV. And after about a half hour, I could never get an answer out of the person from their sales area at their main office. But you can see they have, if you go online, there's more varieties than I wanted to show here. So I just picked out 2. The one with the double door, again, you can modify this with some timber on the inside, treated 2x6s around and put rollers on it where you can cut the floor out and make a frame. And this can roll off of from a telescope, or you can leave it like it is and roll out. And this one, I didn't notice this when I was looking at these a couple of months ago. This one has a slide off. So the front half slides off. So in essence, you can actually open the door, slide this back, and have a telescope in there ready to go. So there are means out there to get a shed rather reasonable. And then these are some of the vendors. I've seen Sky Shed. I'm not sure about At Home in a Dome. Now, there used to be Pro Dome and Home Dome, and that's where the fiberglass ones that we put together came from. But they are becoming more common, or it's very difficult, but I have seen people make their own. And then this website here, I'm sure many of you have gone to this. It lists hundreds of Rolloff and dome observatories. There's nothing wrong with borrowing ideas from somebody, contacting people if they're in your association or anywhere else. Even in the league, there should be a way to get a hold of people with backyard observatories or remote observatories. But there's and I just simply took a quick screen capture, a snippet of Pinterest, because it had all these, and the variety is almost endless that you can come up with. It's your imagination, space, and your desire in order what you can come up with. You have your flip top observatories. Here's one like the Rolloff like a shed. So, it's an endless variety out there. The hardest thing that you're going to have to do is decide what you want. That's really it. What kind of astronomer are you? Are you going to migrate into imaging, or are you strictly going to stay visual? Location. Are you in a cramped urban setting inside the city, or do you have a 1 acre space, or do you have someplace you can go that's remote? Design considerations. What you want to make it out of? Are you going to go with steel siding? Are you insulation, wood? What are you going to use? What kind of siding material? Of course, you want to try to keep the heat sink down. If you're really into, having it a pristine imaging area. Of course, the codes are going to govern a lot of that. Setback distances, covenants. Or you're going to have to get an easement from, have the neighbors sign off on it. Construction documents, check with your municipality. What do you need? When I built my 30 by 50 garage, I built it myself. I only had to get a permit, and they came out and looked at the footing inspection and completion of build, and that was it. And types of construction. The items in the red are really where you have to decide. And I think that's where most people have a hard time with is, do you want to roll off or do you want a dome? Or can you have maybe both? I would like to have one of each and put a solar observatory in a dome and then have the roll off for my general observing. And I want to thank you for spending your time and sharing it with me this evening. I miss Tucson. We try to get out there every year, and I don't have to tell you why we're not out there right now. If you have any more questions, feel free. But I do thank you for having me here tonight, and it is a pleasure, and we enjoy being a member of the TAAA. Thank you.
Thank you so much, Joe. Do we have any other questions that haven't gotten into the chat yet for Joe, or do we have any? Oh, we have a Facebook question for you, Joe, that's typed in the chat.
I'm looking at it. So they're asking, for those in Arizona, is temperature control needed in the shed? I would be afraid to leave my telescope and electronics in a shed during Tucson summers. Maybe somebody out there, I know on the roof at UMKC, it's not uncommon for us to have 4 or 5 or 8 days of 100 degree more high during the day. And it is not climate controlled. So I would defer this to somebody out in Tucson that is more constant of that kind of heat.
Yeah, I could make a comment on that. I've got 2 domes in town and got telescopes and the C14 and the C11. And my experience is, and it gets to be about 1:30 in the dome on a hot summer day going in there. And the thing that actually is the most fragile is the computers. They will not operate. Computers have, at least the computers I've had, have a temperature sensor in them. They get too hot, they just shut off. And so I've got around this by a couple of ways. One, realize that, your computer shuts off. You come back later, the heating is cooler, the computer off is still working. It's just saving itself. And if you're going to put any computer in any remote location, have the computer built so that it has military style motherboards and have 2 power supplies in it for cooling and heating. And then just open up as soon as you can, as soon as twilight starts or late afternoon to cool things off. The equipment's fine. The seeing may be bad and the computer may be flaky until it cools down a little bit, but by and large, it's not really an issue.
And you can't put vents in these things. We've been talking about putting one in the ones up on the roof. The 16-inch actually has a miniature turbine unit, and so we're looking at something like that. So there are some ways to vent that excess heat. The other
does anybody online have any experience with using a vent system, maybe a thermostatic vent system to keep those confined spaces cooler? Guess not. Okay.
Probably down here in Arizona, probably one of the best things you can do if you're going to leave a telescope out is to insulate the building if you can, because that's going to cut down on the heat, and then still put a roof vent on it of some type. My experience with roof vents is you can get the roof vents that sit right on the ridge of the roof and they run the whole length. And those work really good because they let the heat out the top.
Yeah, you can. There's he's absolutely right. Even on my garage, we did that. And you can put a fiber material that's very open to help keep the wasp and mud daubers out of it. So anything, and maybe even something at the bottom, a vent where it can actually aid in the convection process of getting air movement through there. And I see someone had a 3.5-inch Maxitop that the corrector plate was deformed from being outside in the heat. Never heard of such a thing on that.
Use a small air conditioner in my dome.
Yeah, that was mine.
Ah.
Yeah, I had a 3.5-inch Maxitop that I was leaving out in a small shed. My main telescope I was bringing in, so it was in an air-conditioned house. But for convenience, I wanted to leave the little one outside, and I was leaving it outside in the shed, but it was not air-conditioned and not vented, so it probably got to be like 130 or so. And after I had left it out for a few months during the summer, I went to use it and found that it was in bad shape. And I took it to the repair place here in town, and he said the corrector plates got deformed. And he said, yes, it's from the heat. We replaced the corrector plate and everything, and it's okay now, but it's like lesson learned. I don't leave it out anymore.
I often wondered about having a second roof structure on top, even if it's just elevated like a piece of, like the roofing material with insulation, where you have two with the airspace in between. What the difference would be with because it's not directly on top of the observatory.
You put the shed in a shadow.
Yeah, actually, I did it at Boy Scout camp. I used to put a tarp about 10 feet above my tent, and it was a lot cooler in the summer for 10 days than not having that tarp above it. So that could be very inexpensive way to elevate 6 inches a piece of roofing membrane and keep the primary heat off of the main roof.
Hey, do we keep track of the temperature in the observatories, in the CAC observatory and the Rolloff with the 40-inch? Because I don't think the Rolloff with the 40-inch has any kind of active venting or anything. It kind of sits out there in the sun, just painted white. And then the Mitchell Observatory, I'm not really familiar if it has active cooling on it either, but it seems to work.
the 14-inch, the 14-inch at Tempa doesn't have any
Yeah,
ventilation either.
yeah, yeah.
And
Yeah, it
we're
just sits
not,
in that box,
we're not,
right? Make
yeah,
water.
we're not in that roll off, and we're not having any problems with that telescope due to heat.
Okay.
And then we've got all those loner telescopes sitting in that big Connex box that are just sitting in an easy bake oven. And as far as I know, we're not having any problems with any of those.
Yeah, it's the same. It's the same with the Chiricahua Astronomy Complex. None of the protective sheds that we roll off of the telescopes, none of them are vented or temperature controlled. And to date, we have not seen any detrimental effect to the equipment. We don't monitor the temperatures, and they certainly can get pretty warm. The steel storage containers can easily get over 120 to 130 degrees in the summertime.
They probably get hotter than that, John.
Maybe, but again, we have not seen any problems with that.
I know my garage, I measured it with one of those infrared guns, and it was 167 degrees one August. I measured it from the inside.
I could actually do a temperature test on those steel storage buildings. We've got 2 of them sitting out here in the yard. And I could go throw a thermometer in there and check it. See what it gets up to.
Terry, do we have any other comments from Facebook?
None that I see.
Okay.
I think I got them all in there.
Great. Right. Well, thank you so much, Joe. This has been really, really interesting. And I have to say, coming from high humidity areas, I don't envy your 95% humidity at all in any way. So,
Well, I thought about being outside and doing this, but after we got attacked by the state bird, the mosquito, last night, and in one I couldn't get to it in time, and it just had a blood feast on me. When I smacked it, I thought I bled out.
so, well, you certainly are contending with all kinds of issues, but surviving them.
Yeah.
Well, I had a 7-year plan to move to Tucson. I'm in year 12.
Okay.
Yeah, one thing I don't miss are those dang mosquitoes.
Okay, I just got another question. What's keeping you from coming to Tucson?
Well, I'm not retired, and I have had some job interviews out there, actually. They were unsuccessful, but one of them I was very happy to have, and actually impressed that they took the time to set up their first internet interview that was 90 minutes long at Kitt Peak for me.
Super.
But we spend about 6 weeks a year out there.
Oh, okay.
Well, we're delighted to have you as a member living out there, but of course, we'd rather that you move back here. So, we'll hope that occurs as soon as possible.
Me too. My wife's ready to go also.
Great.
Yeah,
She's
that's
off camera, actually.
that's another consideration too. If you're, so you have to consider her needs as well.
Yeah, she said even though we have grandkids that are only 8 years old, she's willing to come out there. And like I said, we've known about a dozen people out there for 15, 16 years or more.
So what do you do for an occupation back in Kansas?
My background is architectural engineering and lighting design. And I was the Antichrist of the astronomer at one time, but I've always had that picture of doing it right. Now, June, I was invited to become a high school teacher. And so I am the high school teacher now.
So what do you teach?
I teach architectural design, drafting, hand drafting, computer drafting, and robotics. I'm hoping after a couple of years and everything is set, I can move into astronomy and also get a observatory at the school.
Okay.
And I guess I can mention this. I'm also, a few of you know that's here tonight, I am the new president of the National Sharing the Sky Foundation. David invited me a couple of years ago to move into that position.
Okay. So how are your skies where you're at?
We can see the Milky Way.
Oh, you can? Okay.
Yes, we're about 40 miles northeast of downtown Kansas City, Missouri. We have I want to say maybe 1,500, 2,000 acre state park across the street from us. And so we have a better sky than we do down at Powell Observatory down south of Kansas City.
At who observatory?
It's called PAL. It's by the Astronomical Society of Kansas City, the ASKC.
Uh-huh.
And then I manage the one at the university that I had the pictures of. So on Friday nights, I'm generally down there. And we plan on opening it up to the public next week.
Uh-huh.
Well, you're just doing all kinds of great things, Joe.
Yeah,
So,
it's
again, thank you so much. And you're going to have more time with Joe because he's going to do a breakout room with us later tonight. So, so he'll be here and you can continue to chat with him, enjoy him a lot.
And then I'll be jumping online with Don McCarthy and talking to him tonight.
Well, super. Okay. Thank you so much.
Thank you, everybody.
Okay. I think now next we have an announcement. Terry, I don't know if you have a slide for that.
It depends on which announcement.
The Grand Canyon Star Party? Okay, so anyway, we wanted to remind you that the Grand Canyon Star Party for this year starts tomorrow night, goes June 5th, Saturday, June 5th through Saturday, June the 12th. And it, of course, is all virtual this year. We're really planning on having it in person next year. But there's a lot to enjoy this year. At 7:30 each night will be a speaker presentation. And this year they're emphasizing cultural aspects of astronomy. So each night there will be some information about a different culture and how it relates to astronomy. And then after the 7:30 lectures, there will be a star party each night at 9 p.m., virtual star party. And for you to connect with this, you can go to the Grand Canyon webpage. That there's the address, up there, and get more information about what's happening, when, at what times. And then you can also go to YouTube, the Grand Canyon YouTube channel, to participate. And you might want to pay particular attention to the TAAA nights that are presentations for star parties. And that is, the first one is Saturday, June 5th. So the first night there is a star party, TAAA will do. So Saturday, June 5th, Monday, June 7th, and Thursday, June 10th will be the star parties that are done by TAAA members. So, and they worked many hours and really hard on doing those. And so I hope that you get to see those, but you know, the event, wherever you get to watch, should be a really nice experience. Okay, and then next we have David Levy, who is going to do a poem.
Well, thank you, everybody. Thanks, May. And before I do my poem tonight, I want to personally thank Joe Wright for his wonderful talk. Wendy and I thought it was easy to hear, explained very clearly and very well. We love seeing the pictures you showed of our observatory, and we need for you to come out here to see that that building has been completely rebuilt in the last 6 months. And I think you would enjoy seeing that. Tonight's poetic quotation will be from Tennyson's In Memoriam, and I think May would actually have kittens if I plan to quote the whole thing. So how about I just quote 3 stanzas from it. 2 of them I found in Jonathan Tennyson's office. Jonathan Tennyson is the poet's great-great-grandson, and he is an astronomer, and I got to meet him a few years ago. There rolls the deep where grew the tree. O earth, what changes hast thou seen? There where the long street roars hath been the stillness of the central sea. The hills are shadows and they flow from form to form and nothing stands. They melt like mists, the solid lands, like clouds they shape themselves and go. And the third one is a time to sicken and to swoon when science reaches forth her arms to field from world to world and charms her secret from the latest moon. This is Tennyson's thoughts about moons. And of course, I think he went planets in this case. I think the poem In Memoriam came out in 1850. Neptune was discovered only 4 years earlier. He's probably referring to Neptune, but that's not what I'm referring to. I am referring to an announcement that I would like to make tonight, and I would like to congratulate David Rossiter. David is a member of the organization. He's been a member for a couple of years now, but Wendy and I met him at our Adirondack Astronomy retreat. He had a telescope called Fritz, he still has it, 25-inch, that when you looked through it at M15, you weren't looking at M15. You were walking through the streets and parkways and alleyways between the stars of that lovely globular cluster. Never forget it. And tonight, I wish to announce that asteroid number 545394 has been approved by the International Astronomical Union to be named Rossiter. And the citation is that David Rossiter is an experienced visual observer of the night sky. His vast experience, particularly with the summer sky, has enhanced many years of the Adirondack Astronomy retreat in New York State, and he has inspired hundreds of people to enjoy the sky. Tonight, as David and Pam are on their way north, we wish them safe driving, comfortable vacation, and see you guys soon. And now back to you, May. Thank you so much.
Okay, thank you so much, David. I appreciate that. And I had not heard about the asteroid naming. So we appreciate you revealing that, what evidently David was keeping a secret from us. And now we will know his secret. So well, I want to, at this point, I don't know that I want to, but I need to say goodbye to our Facebook people. We're really glad that you came and joined us tonight. We're here the first Friday of every month, and we hope that you will check us out because we have a whole variety of different kinds of presentations that are really we think interesting, and maybe hit different interest levels at different times. But we also hope that you will check out our website. We have lots of information about astronomy on our website, and hopefully things that whatever level or interest you have in whatever level you are and whatever interest you have in astronomy, you might find something that would be valuable to you from looking at our website. And of course, on our website is a nice little place where you can join. And so if you're interested in that, we would just be delighted to have you as members as well. But thank you for joining us tonight, and we hope to see you again soon. And please pay attention to the information about the Grand Canyon Star Party that starts tomorrow night. And so that's it's going to be 8 nights in a row. So maybe somewhere in there you will have time to join that event and have that experience as well. So we will see you soon. Every June, even though you've had the election results given to you before for the election, we also in June, we mention the officers to you that start June 1st and go till June 1st of the next year. So this year we have for Vice President Ed Foley is here. If we can find Ed Foley.
A little slow finding people.
Oh, well, that's all right. You have lots of people.
Automatically alphabetically.
We have you have lots of people to look through, and it's no problem, Terry. We can actually pause and take a breath.
So there's Ed.
Okay, so great. Thanks, Ed. For secretary this year, we have Bob Reynolds. I don't know if Bob is here tonight.
I don't see him.
Okay. For treasurer, we have Mike McDowell, and I didn't see Mike tonight either.
Nope.
Okay. And our members at large, we have Gus Gomez.
He's not in here. He's on his way back from El Paso.
Oh, okay. Thank you for
I
letting us
talked to
know.
him already.
Thank you, Ralph. And then we have Ralph.
Wave, Ralph.
Yes, wave Ralph so people know that.
Well, if here, I'll use this one.
Well, and you kind of you have a little bit of a light glare where you are,
yeah,
so it wipes out your face.
That's Dad's computer screens.
Okay.
And
so,
the light up there.
Great. Oh, that helped, Ralph. Thank you. And then we also have Doug Smith, who's here. Great. Thanks, Doug. And then I will be continuing as president again. So we have a nice full board with people who've done lots of work at different times and TAAA and lots of different areas. And so we should have a great year this year. I think we're now ready, Terry, for people to go to the breakout rooms.